SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, SoundCloud, YouTube, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, Rosetta's missing Philae lander finally found. New Trans Neptunian objects discovered in the search for Planet 9. And the Sentinel-1A spacecraft damaged after being struck by space debris. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Rosetta's missing Philae lander has finally been found, less than a month before the end of the orbiter's historic mission to the Comet 67P Churyumov-Gerasimenko. The tiny lander went missing during its touchdown on the surface of the 5-kilometre wide comet back on November the 11th, 2014. Rosetta's high-resolution camera spotted Philae wedged on its side in a dark crack on the comet's surface in the Abydos region of the comet's smaller lobe. The discovery was made on September the 2nd by the OSIRIS narrow-angle camera, as the Rosetta orbiter came within 2.7 kilometres of the comet's surface. The image clearly shows the main body of the lander wedged on its side with two of its three legs visible. The new findings show how Philae's final orientation would have made communications with the orbiter almost impossible, and also why the lander wasn't able to use its solar panels to recharge its batteries. Because of Comet 67P's low mass, and consequently its lack of significant gravity, Philae was supposed to use a push jet and a combination of grappling hooks and ice drills to anchor itself to the comet's surface as it landed. However, both the push jet and the grappling hooks failed to activate, resulting in the lander bouncing back up into the sky upon touchdown. During the 2-hour bounce which followed, Philae is thought to have hit the ground at least once more before finally coming to rest on its side in a narrow shaded ditch, or as it turned out, an even narrower, darker crack. After 3 days, Philae's primary battery was exhausted and consequently the lander went into hibernation mode. It woke up again to briefly communicate with the Rosetta mothership in June and July of 2015 as the comet came closer to the Sun during its perihelion, allowing more power to reach the shaded solar arrays. However, until now the precise location of the lander wasn't really known. Radio ranging data tied its location down to an area spanning a few tens of metres, but a number of potential candidate objects, identified in relatively low-resolution images taken from larger distances, couldn't be analysed in detail until recently. While most of the candidates were quickly discarded from this analysis, evidence continued to build towards one particular target. That last remaining target was finally confirmed to be the Philae lander. The image was taken by the Rosetta orbiter at an altitude of just 2.7 kilometres, the closest the spacecraft has so far been to the surface of the comet. At that altitude, the resolution of the OSIRIS narrow-angle camera was about 5 centimetres per pixel, more than sufficient to reveal Philae's microwave oven-sized body. Now that the lander search has finally been concluded, European Space Agency mission managers feel ready for Rosetta's own landing on the comet's surface. That's slated for September 30, when the orbiter will be sent on a final one-way mission to investigate the comet close up, including open pits at the Marat region, where it's hoped that critical observations will help to reveal secrets of 67P's interior structure. Astronomers searching for a proposed ninth planet have detected several never-before-seen small Trans Neptunian objects at extreme distances from the Sun in the outer solar system. The new discoveries, reported in the Astronomical Journal, could help planet hunters narrow down the size and distance from the Sun of the predicted ninth planet. That's because the hypothetical planet's gravity influences the movements of smaller objects orbiting far beyond Neptune. The new discoveries by Carnegie University Scott Shepard and Chadwick Trujillo from the Northern Arizona University have been submitted to the International Astronomical Union's Minor Planet Center for official designations. Shepard and Trujillo, together with Caltech astronomer Mike Brown, predicted the existence of a ninth planet out beyond Pluto following observations of unusual orbits by several Kuiper Belt objects. Of course, Mike Brown's involvement in the Planet 9 hypothesis is poetic, as it was his discovery of the Trans Neptunian object Eris which led to the demotion of Pluto from planetary status in 2006, placing it instead into a new category of so-called dwarf planets. In 2014, Shepard and Trujillo announced the discovery of 2012 VP-113, nicknamed Biden, which has the most distant known orbit in our solar system. At the same time, the astronomers also noticed that a handful of known extreme trans-Neptunian objects all cluster with the same orbital angles. It was this discovery which led to the prediction of a planet orbiting the Sun at a distance of over 200 astronomical units, 5 times more distant than Pluto. An astronomical unit is the average distance between the Sun and the Earth, which is roughly 150 million kilometres. If they're right, Planet 9 will be out there on a highly elliptical and inclined orbit, just waiting to be discovered. Analyses of neighbouring small body orbits suggest that Planet 9 is several times more massive than the Earth, possibly as much as 15 times or more, placing it into a similar category to the ice giants Uranus and Neptune. The newly discovered objects submitted to the Minor Planet Center for designation include 2014 SR349, which has similar orbital characteristics to the previously known extreme bodies whose position and movements initially led to the Planet 9 hypothesis. Another extreme object the team discovered is 2013 FT28, which has some characteristics similar to other extreme objects, but also some which are quite different. FT28 shows similar clustering in terms of its semi-major axis, its eccentricity, its inclination, and the argument of perihelion angle. However, one of these parameters, an angle called the longitude of perihelion, is different from that of the other extreme objects, which makes that particular clustering trend less strong. A third discovery, 2014 FE72, is the first distant Oort cloud object found with an orbit entirely beyond Neptune. In fact, it has an orbit which takes it more than 3,000 astronomical units out from the Sun, far enough in fact that it's likely to be influenced by the gravitational pull of other stars as well as the galactic tide. Shepard and Trujillo, together with David Tholen from the University of Hawaii, are conducting the largest and deepest survey so far for objects beyond Neptune in the Kuiper Belt. At the moment, they've covered about 10% of the sky. As they find and confirm extremely distant objects, they analyse whether their discoveries fit into the larger theories about how interactions with a massive distant planet could have shaped the outer solar system. And the greater the numbers of extreme trans-Neptunian objects detected, the better science will understand the structure of the outer solar system. Physicists say a new theoretical particle called the Madala boson might help explain dark matter. Understanding dark matter is one of the biggest puzzles in science today. The mysterious substance makes up some 80% of all the matter in the universe, yet it can't be seen and can only be detected indirectly through its gravitational influence on normal matter. Researchers with the High Energy Physics Group at the University of Witwatersrand in Johannesburg have begun sifting through data from the particle collisions which led to the 2012 discovery of the Higgs boson at the European Organisation for Nuclear Research's CERN particle accelerator, the Large Hadron Collider. The team are now searching for evidence of another hypothetical boson or force particle, which they've named the Madala boson. Their hypothesis is based on particle collisions at the Large Hadron Collider, which may have provided some tantalising clues of possible features and peculiarities of the proposed new boson, which would generate a field similar to the Higgs field, which gives particles their mass. The Higgs has no charge, no spin, a mass of 125 gigaelectron volts, and interacts with particles in the standard model. The hypothetical Madala boson would instead interact with dark matter, whatever that turns out to be. The discovery of the Higgs boson completed the standard model of particle physics, which describes interactions between particles and forces and underpins science's understanding of the universe. The problem is, the standard model can't explain dark matter or dark energy, which combined makes up some 96% of the mass energy budget of the universe. Whether the hypothetical Madala boson can explain this, or for that matter whether it even exists, is yet to be resolved. The European Space Agency's Sentinel-1A Earth observation satellite has been damaged by impacting space junk. The impact, which occurred at an orbital altitude of about 700 kilometres, punched a 40-centimetre wide hole through one of the spacecraft's solar panels. Mission managers in Darmstadt, Germany still aren't sure what the impacting object was. However, they think it was only a few millimetres in size, as anything over 5 centimetres can be tracked by the United States Air Force Space Command. Mission managers first became aware of the impact when power suddenly dropped from one of the probe's solar arrays. Engineers then activated onboard cameras originally used to monitor the deployment of the solar wings to check out the array, finding evidence of an impact hole in one of the panels. Luckily, the damage isn't severe enough to abort the mission, as the spacecraft has redundancy capability. The Copernicus Sentinel-1A is part of a constellation of spacecraft studying Earth's environment from orbit. As well as monitoring natural disasters, the spacecraft are also studying the worsening problem of human-induced climate change. This latest incident has served to again highlight the dangers of orbiting space junk, which poses a growing threat to both spacecraft and their crew. Three Expedition 48 crew members have returned safely to Earth, following their 172-day mission aboard the International Space Station. Their Soyuz TMA-20M capsule parachuted down to an early morning landing on the windswept Kazakhstan steppe 3 hours and 22 minutes after undocking from the orbiting outpost Poisk module. The crew had conducted hundreds of experiments in biology, biotechnology, physics and earth sciences during their stay on station. They also undertook 2 extravehicular activities, or EVAs, NASA speak for spacewalks. One of these involved fitting the new International Docking Adapter, or IDA. It's designed to provide automatic docking facilities for a range of spacecraft. The other EVA involved spacewalkers stowing an unused radiator and installing hardware for a new system of external high-definition cameras. The Expedition 48 flight also saw the installation and inflation of the Bigelow Expandable Activity Module, or BEAM, an experimental inflatable module technology demonstrator which can be packed away into small areas for transport and then inflated to provide a large pressurized living area. Beam modules have the potential to play a significant role in future deep space missions and eventually for manned flights to Mars. The Expedition 48 crew's return to Earth was also significant in that it was the last flight of the Soyuz TMA-M capsule. All Russian manned missions are now operated using the new Soyuz MS spacecraft, the first of which was launched back on July the 7th on a Soyuz FG rocket bound for the International Space Station. The new MS capsule looks similar externally to the older TMA-M, but it features new external antennas and sensors, as well as more efficient solar arrays. It also uses 28 high-thrust DPOB thrusters arranged in 14 pairs, replacing the 16 high-thrust and 12 low-thrust units, which were arranged in 2 separate circuits on the older TMA-M Soyuz. Internally, the Soyuz MS uses new computers, upgraded communications and navigation subsystems, and improved telemetry data systems. The 3 remaining astronauts aboard the space station will soon be joined by 3 new Expedition 49 crew members slated to launch aboard the Soyuz MS-02 from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan on September 23rd. It's been a busy time for crew aboard the International Space Station. As well as bidding a fond farewell to crew members aboard the Soyuz capsule, a Dragon SpaceX cargo ship carrying over 1,400 kilograms of scientific experiments and equipment has also undocked from the space station, splashing down in the North Pacific Ocean. The Dragon CRS-9 capsule had been berthed at the orbiting outpost for just over a month on a resupply mission. The Dragon's re-entry flight began with the space station's robotic arm undocking the capsule from the Harmony module and moving it away from the orbiting outpost. 2 initial rocket engine burns by the Dragon's Draco thrusters then manoeuvred the capsule to a safe distance about 200 metres from the space station. Dragon then carried out a 180-degree roll, followed by a third rocket burn, placing itself 150 kilometres away from the orbiting outpost. 5 hours later, when the Dragon was at just the right location for atmospheric re-entry and splashdown, the spacecraft lit up its thrusters one last time for a massive 10-minute engine burn. That slowed the Dragon down from its orbital speed of 28,000 kilometres per hour, allowing it to drop out of orbit. 6 minutes after the spacecraft began EDL, or entry, descent and landing, Dragon jettisoned its service module, exposing its protective heat shield. 24 minutes later, the plummeting spacecraft reached re-entry interface, hitting thicker layers of the upper atmosphere at an altitude of about 400,000 feet. As the fiery descent continued, the heat shield began experiencing temperatures of over 1600 degrees Celsius. About 10 minutes before splashdown, at an altitude of about 45,000 feet, 2 supersonic drogue parachutes were deployed to begin slowing the spacecraft down. Dragon's 3 main parachutes were unfurled at an altitude of 10,000 feet, allowing the capsule to gently float down to a splashdown 523 kilometres west of Baja, California, in the North Pacific Ocean. The splashdown occurred just over 5 hours after the Dragon undocked from the space station. After splashdown, the capsule was quickly retrieved and placed aboard a recovery ship where time-sensitive experiments were removed. The Dragon was then shipped to SpaceX's McGregor facility, where it was safed and the remaining cargo unloaded. And time now to turn our eyes to the skies. The September skies have provided a real treat for sky watchers. We've already seen a spectacular annular eclipse over Central Africa and the Origids meteor shower, which provided up to 5 swift and bright meteors per hour at its peak shortly before dawn on September the 1st. The Origids are produced as the Earth passes through the debris trail left behind by the comet KSC 1911 N1, a long-period comet which only reaches the inner solar system roughly every 1800 to 2000 years. This year's event occurred on a new moon, providing nice dark skies for viewing. The Origids are best viewed from the northern hemisphere, as its radiant, that is the direction the meteors appear to be coming from, lies in the northern constellation of Central Auriga. The second meteor shower of the month, the Epsilon Perseids, is on tonight, and with the first quarter moon setting at midnight, the timing should be good for best viewing just before dawn. Although they're called the Epsilon Perseids, the radiant actually lies closer to Beta Perseus. The Epsilon Perseid shouldn't be confused with the Perseids meteor shower in August, because while they both appear to have their radiant in the constellation Perseus, they're actually caused by debris trails from 2 separate comets. And now, with more on the September night skies, I'm joined by Jonathan Nally, the editor of Australian Sky and Telescope magazine.
Well, during the evenings of this time of the year, the Milky Way is stretching beautifully from north to south across the sky. If you're in a dark location, if you're out in the country, out in the bush somewhere, and you get outside and away from the lights, then you'll see the Milky Way just absolutely magnificent, sort of straight overhead from the north way down to the south. And the central parts of the Milky Way, our actual galaxy, are actually right overhead at the moment for people in sort of mid-southerly latitudes, about the latitude of Sydney or near enough to. So it's absolutely beautiful. If you're in the city, I'm afraid, you're probably going to struggle to see the Milky Way because of all the light pollution, but just do your best, see how many stars you can see. The Southern Cross, which is the constellation everyone wants to see, is way down low in the south at the moment. It's lying on its right-hand side, almost directly south, in fact, and very low on the horizon, so you need to make sure you haven't got houses and trees and things in the way if you want to try and spot it. The 2 famous pointer stars, Alpha and Beta Centauri, which point towards the cross, well, they're sort of above it and pointing directly down, so that should help you to find the Southern Cross. Now, let's run through the planets. The ones that are really prominent at the moment are Saturn and Mars, and just like those constellations, they are right overhead at the moment for people in sort of mid-southerly latitudes. They're right up there, right overhead, beautiful, easy to see. They form a nice broad triangle with the star Antares, which we mentioned on the show before. This is the brightest star in the constellation Scorpius. Now, both Mars and Saturn look like bright stars, but they're not stars, they're planets. Mars is a sort of a reddish colour. Saturn's a slightly yellow colour. Now, when you look at them, Mars and Saturn and the star Antares, just think of this. Mars, at the moment, it's about 146 million kilometres from Earth. 146 million. Saturn is more than 10 times further away. It's more than 1,500 million kilometres away from us. And the star Antares, what would you think that is? Well, that's about 500 odd light years away from Earth, which is about 5,000 million kilometres away. And Antares, by the way, is 800 times bigger than our sun. It's an enormous, enormous star. So when you look up there, don't just think the little dots of light in the sky. They're real amazing things out there in space.
Now, I take it because of its reddish hue, that means it's a red supergiant?
It's a red supergiant, yeah, it is really supergiant. I said that Mars is about 146 million kilometres from Earth at the moment. Mars is the next one out from Earth in terms of order from the sun. Well, if you took the sun away and put Antares in the middle where our sun is, its outer limit would stretch out further than Mars. It would stretch out to about halfway between Mars and Jupiter. That's how big that star is. I mean, it's just ginormous. We're lucky we have our sun. Our sun's a really nice star. Now, speaking of other really nice things, Venus, the planet Venus, is the bright object out in the western sky after sunset. If you see a really bright star out there, really bright, brighter than anything else around it, that's not actually a star, that's the planet Venus, and it can't be missed because it's the brightest thing in the sky after the sun and the moon. It doesn't look much through a telescope, so just enjoy it with the naked eye while it's up and about. The planet Mercury, which can sometimes be seen low in the east before dawn or low in the west after sunset, it can't be seen at all at the moment because it's between us and the sun, and it won't be seen easily again until November, when it will pop back into our evening skies. Jupiter's out of view at the moment too, being on the other side of the sun from us, so we can't look through the sun, so we're going to have to wait until it comes back into view in our dawn sky in late October. And let's not forget our planet Earth. We've got a bit of a milestone coming up in September, always happens in September. It's the equinox, of course, on September the 23rd. For us in the southern hemisphere, it's the spring equinox. For the people who live in the northern half of the planet, it'll be the autumn equinox. And the equinox is when the sun is right over the equator. So if you live on the equator, around the time of the equinox, the sun will be rising due east and setting due west.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. NASA has successfully tested its RS-25 rocket engine, which will power the agency's massive new Space Launch System SLS rocket, designed for deep space missions to the Moon, Mars and beyond. The 7.5-minute full-thrust test took place at NASA's Stennis Space Center in Mississippi. The reusable Aerojet Rocketdyne RS-25 isn't a new engine. In fact, they were originally built for use as the Space Shuttle's main engine, successfully powering the winged orbiter on 135 launches. The liquid hydrogen and liquid oxygen cryogenic engines each developed 512,000 pounds of thrust at 109% for the 8.5-minute ride into orbit. Each SLS main stage will be powered by 4 RS-25s and 2 5-segment solid rocket boosters, which are also based on the SRBs used aboard the Space Shuttle. This combination will provide NASA with the most powerful launch vehicle ever built. The new rocket will be the launch vehicle for NASA's new Orion capsule, designed for deep space missions. Orion was launched on an unmanned test flight aboard a Delta IV Heavy rocket back on December 5, 2014. The SLS is slated to carry out its maiden test flight in September 2018. NASA says the SLS will be upgraded over time, with even more powerful versions being built. Its initial Block 1 version is designed to launch payloads of up to 70 tons into low Earth orbit, while later Block 2 versions will lift over 130 tons. That's almost as much as the legendary Saturn V Apollo moon rocket, which could lift 140 tons into low Earth orbit and more than 48 tons into lunar transfer orbit. And finally for now, NASA and the United States Naval Research Lab have just set a new Guinness World Record for the most rocket engines installed on a single launch vehicle. The Charged Aerosol Release Experiment 2, or CARE-2 sounding rocket, was fitted with 44 small engines. Sounding rockets are small missiles designed to take scientific payloads on high-altitude ballistic trajectory flights. The mission was designed to study dusty plasmas, charged particles or plasmas which contain nanometer-sized grains that can form in the upper atmosphere. These dusty plasmas can be created both naturally and also from rocket exhausts. Only 3 of the 44 rocket motors were used for the launch, while 4 others were used to control the rocket and maneuver the spacecraft once it was airborne. The remaining 37 motors were all used to help create dusty plasmas in the ionosphere. Plasma detectors on the rocket and ground-based radars were then used to study the dusty plasma's behavior. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from spacetimewithstuartgary.com. The show is also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is Spacetime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for Spacetime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, this month exploring the mystery of fast radio bursts.